Hello everyone and welcome to the next session of Core Java. In this session, in continuation with polymorphism, we are going to discuss about what is compile time polymorphism and how to achieve it. So polymorphism we have already discussed as when one entity is available in multiple forms at the same time, it is termed as polymorphism. Now, how many forms of entities will be used at once? Answer is 1. So only one entity will be used at once. Now, out of all those multiple entity forms, which form is being used at a certain point? If it is known at the time of compilation, it is termed as compile time polymorphism. And compile time polymorphism is implemented through method overloading. Now, what is method overloading? One method is implemented in multiple forms within a class where the method name is same, however, other parameters will be different. So let's look at this compile time polymorphism through a code. Say for example, I have a class demo and this class has got a method. Now let's first understand what is the signature of a particular function. What is included in that? So first of all, the signature will have access modifier. Then the return type. Then method name. And then we have parameters to be passed, parameter or parameters to be passed to that particular method. So this is nothing but the method signature. So let's say for example, I have public void add and it is not taking any parameter. This is one method. Now I'm not going to go in the details of method implementation. So this is one method where access modifier, return type, method name and 0 parameters. Now how I will be able to overload this particular method? First of all, say for example, I'm keeping access modifier as public, return type is int, and I'm going to keep method as add, name will be same, and I will pass one parameter to it. And for time being, because otherwise I will get compilation error, I am returning some value, say I plus 10, something like that, right? So what I have changed the return type, I have changed the number of parameters. Now remember that changing this return type is not part of method overloading. You may or may not be changing the return type. What makes sense for having implementation of method overloading is number of parameters which you have passed. So the first rule for having a method overloaded is number of parameters passed to each form of method must be different. Method name we are going to keep same as add. So we can say that one entity is available in multiple forms. Now I'm creating another method which is accepting two parameters. So is this method overloading? Yes. The answer is yes. All these three methods are overloaded. One method is available in three forms. One method accepting 0 parameters, another 1, and one more accepting 2 parameters. So as number of parameters passed to each of this form of method are different, that means this method is overloaded. So first rule is every method must have different number of parameters to be passed. Then I will make access modifier as default, no public private protected, so it is default. And I am passing again one parameter. Now here I have passed one parameter, here also I have passed one parameter. So is it method overloading? Answer is yes. It is still method overloading because type of the parameter which is passed is different. The second rule for method overloading is type of the parameters which we have passed to any method must be different. And say for example int I float f. So whatever number of parameters I have and void add float f and int I. Again, is it method overloading? First of all, here 0 number of parameters, 1, 2, 2, 1. So these are all forms of method overloading, right? But then again here I have two parameters. One is int, another is float. Here also one is int, another is float. So is it really method overloading in these two forms of methods? The answer is yes. This is also method overloading because here we have changed the sequence order of the parameters which are being passed to this add method. So one method is available in 1, 2, 3, 4, 5, 6 forms at the same time. This is nothing but method overloading. So this is about method overloading. Now we are going to have a look at how we will be able to achieve compile time polymorphism through this, right? So what I'm going to do over here is I'm creating object of this particular class. Then I'm calling this method demo add, demo.add pen, demo.add say hello. Maybe I'm adding this string to something. Then add int, so 12, something like this. Demo.add and demo.add. Okay, I will pass float and int. Now, I claim that through this, we have achieved compile time polymorphism. Compile time polymorphism means what? When one entity is available in multiple forms and which form of entity being utilized at runtime, because method will be called at runtime. But which form of entity will get utilized, it is known at the time of compilation. So what compiler is going to do? Compiler checks two things. One is syntax and another is the method calls. Okay. So what it checks is, okay, here an object of demo class is created. Is syntax correct? Yes. Here, demo.add. So whether this add method can be called using object demo, right? This variable demo. Now the answer is yes. When can we call a particular method which belongs to a class? When we create an object of that class. Or in other ways, An object can call a method which belongs to that particular class. So is this function call valid? Yes. So compiler has done that. Now compiler also checks that whether there is add method available in this particular class. Answer is yes, there is add method. Rather, there are multiple add methods. So, is there add method which does not accept any parameter? Right? So, is there any add method which does not accept any parameter? And this is the method which will be executed. So, compiler knows that at runtime, this form of entity will get executed. What about this? Whenever I'm calling this method and passing one int parameter, what happens over here? There is add method which is accepting one int value. That means this form of entity will get executed. Like this, all these method calls will be checked by the compiler, and compiler is aware that exactly which form of entity will get utilized. So in this way, through method overloading, we can achieve compile time polymorphism. Thank you.